Okay, this video will cover the remaining two examples in the notes of synthetic division, both of which are not in the proper form to start. So they're two of the, quote, hard examples, although let's be honest, it's really not that bad. Now if we look at example B, we should notice that we do have all of our terms, so that's kind of nice. We don't have to add any zeros, but this is not in the form x minus r. So to start off with, we need to divide everything in the entire problem by the number in front of c so that this will become 1c. That would change this problem into 2c cubed minus 17/3 c squared plus 2c plus 8/3 divided by c minus 4/3, which is necessary. It has to be in the form variable minus number in order for synthetic division to work. So in this case, our R value is positive 4/3. So we put R in the box. 4/3 goes in the box. And outside the box, we write those coefficients. 2, negative 17/3, 2, 8/3. Leave one line of space for work. And here we go. Drop the 2. 4/3 times 2 is 8/3. Add down. That would be negative 9/3. Negative 3. 4/3 times negative 3 is negative 4. Add down is negative 2. 4/3 times negative 2 is negative 8/3. Add down. Hey, look, we got lucky. There is no remainder. This is to indicate that sometimes this does work out nicely. In which case our answer here would be 2c squared, because remember, c cubed divided by c would be c squared, minus 3c minus 2. And that would be our answer. Again, your answer should always be 1 degree less than the original problem. So the original problem was a cubic, a degree 3. Your answer should be a quadratic, a degree 2. The final example of synthetic division is this one here. It's really going to test you, because if you don't notice, you need to look closer. There are 2 terms missing, and we're not in the correct format. So in order to get into the correct format, we're going to have to divide everything in the whole problem by 4. Some of those reduce, some of those divide evenly, actually they all either divide evenly or reduce. And we're also going to need to insert a 0y cubed and a 0 between the y squared and the numeric term. So this will become 2y to the 5th minus 1/2 y to the 4th plus 0y cubed minus 4y squared plus 0y plus 1 divided by y minus 1/4. So our R value is 1/4. That goes in the box. And 2, negative 1/2, 0, negative 4, 0, 1 would be the numbers outside the box. Drop that first term straight down, so 2. 1/4 times 2 is 1/2. Add down, that's a 0. We've never had this before, so we'll talk about how to deal with it here in a minute. 1/4 times 0 is 0. Add down, still 0. 1/4 times 0 is 0. Add down, negative 4. 1/4 times negative 4 is negative 1. Add down is negative 1. 1/4 times negative 1 is negative 1/4. Add down, we have a remainder of 3/4. So again, we're going to start off writing our answer with a y to the 4th attached to the first term, because that's 1 degree less. This is a degree 5, which is called a quintic. Our answer should be a degree 4 or a quartic equation. So that would be 2y to the 4th plus 0y to the 3rd plus 0y squared minus 4y minus 1 plus 3/4 divided by y minus 1/4. And again, we have to deal with that remainder. So there's actually 2 things we can do to clean this up. The first is to multiply the remainder by 4 over 4. And the second is we don't really need to include the terms that have 0 coefficients. So our answer should be 2y to the fourth minus 4y minus 1 plus 3 over the original divisor 4y minus 1. And if you leave the 0 terms in there, that would not be incorrect. Okay, hopefully you've got a decent idea how to synthetically divide, because again, this is going to be a major skill, and we're going to use it a lot over the next month of class. Thank you for your time.